Hello my dear. So in the last class we discussed about the swing equation. It's very important. So the steady state analysis can be done with the help of a swing equation. So that m into d square del by dt square equal to pm minus pe. That equation is very important. Directly I already told you that directly the question will be asked by asking the equation itself. Okay, by asking the equation itself. So that much important. So today we are going to discuss about the swing equation for a two machine system. Normally maximum two machine system will be asked, not more than two will not be asked. Okay, so what will be the swing equation for two machine system? Suppose two machines or alternators are operated in parallel or in a system, in a power system, then what will be the swing equation? Okay, so consider my dear, there are two cases for that actually. First one, coherent operation. So coherent operation is nothing but, my dear, the frequencies are same, f1 equal to f2 equal to simply f, and del 1 equal to del 2 equal to del. So this is termed as the coherent operation. So the load angle or the power angle are same, also the frequency of two machines are same, is called the coherent operation. So consider two alternator, my dears. Consider two alternator. Let be G1 having an inertia constant of m1 and G2 having inertia constant as n2, which is connected to a bus. Okay, which is connected to a bus, and it's del 1 and it will be del 2. Del 1 and del 2 are equal. Okay, we will discuss like, and this can be equivalent to an alternator, single alternator having G and inertia constant m and connected to a bus bar. So this m is nothing but, my dear, m equivalent, or G is nothing but, my dear, G equivalent. G is nothing but G equivalent. Okay, so G1, G2 and G equivalent and m equivalent. So we have to find what will be the swing equation for a two machine system which operate in coherent manner. Coherent manner means same coherent source. You already heard na, same source na, in case of light, coherent source. So in coherent operation, in the case of an alternator, is nothing but, my dear, is nothing but the frequency are same and del 1 equal to del 2 is equal to del. So what is the general equation for swing equation? General swing equation is what? For machine 1, I can say like m1 into d square del 1 divided by dt square equal to pm1 minus pe1 for machine 1. Let be equation number 1. And for machine 2, it will be m2 into d square del 2 divided by dt square equal to pm2 minus pe2. Let it be equation number 2. And we have, my dears, suppose if you add 1 plus 2, what we will get? m1 into d square del 1 by dt square plus m2 into d square del 2 by dt square. Since del 1 and del 2 are same, I already told you coherent operation means del 1 equal to del 2 equal to del. Since del 1 and del 2 are same quantity, then we can in the LHS as m1 plus m2 into d square del by d square del by dt square is equal to, in RHS side it will be nothing but, my dear, pm1 plus pm2 minus of p1 plus p2. Is it clear, my dear? Is it clear? So this can be written like m1 plus m2 is nothing but m equivalent. M equivalent is d square del by dt square plus, not plus, it's simply equal to pm equivalent minus pe equivalent. Pm equivalent minus pe equivalent. This equivalent I can like this. You can say like pm equivalent minus pe equivalent. So this will be the swing equation of a two machine system which are coherently operating, where m equality is nothing but, my dear, m1 plus m2. That means simply if you have two machine system and suppose someone asks you to find the string equation, then m equivalent is nothing but the addition of individual m, that is m1 plus m2, and pm equivalent is nothing but corresponding pm1 plus pm2. pe equivalent is nothing but, my dear, pe1 plus pe2, pe1 plus pe2. So that is the general equation for a two machine system. General equation for a two machine system. Next you have to discuss about the case 1. This is nothing but, my dear, coherent operation. Next, B, non-coherent operation. So what is meant by non-coherent operation? Non-coherent operation means frequency will be definitely same, there will not be any change, because if the frequencies are different, then we can't synchronize the alternator, right? So frequency will be of course same, so no need to indicate or separately mention that. But del 1 not equal to del 2. Del 1 not equal to del 2, my dears, that is the meaning of a non-coherent operation. That is the meaning of non-coherent. Incoherent, correct word is incoherent. Okay, it's like incoherent operation. So del 1 will not be equal to del 2, and as well as frequency will be equal to frequency will be same, so we don't want to consider that, I mean, as a separate. So what will be the diagram? The diagram will be similar, but we have to take one case now. One case we have to take. So let del 1 greater than del 2. We have del 1 not equal to del 2 actually, but we have to assume any cases now. Simply del 1 not equal to del 2, we can't analysis more. If you want to analysis more means we have to assume whether del 1 is greater or del 2 is greater, or we have to assume. So what is the meaning of del 1 greater than del 2? What is the meaning of del 1 greater than del 2? That means the load angle of generator 1 will be greater than the load angle of generator 2. So what happens when load angle increases? What is the meaning of load angle increases? Means the speed will be high, right? For machine 1, the speed will be higher than that of the machine 2. That is the meaning of the load angle is increased for machine 1 than machine 2. So what happened, my dear? The result, real power will always flow from higher load angle to lower load angle machine. This is very important, very important term, my dear. So always real power will be flow from. That means whenever we increasing the speed, one alternator, suppose G1, suppose this is the first alternator, this is the second alternator. If we increasing the load angle of G1 means we are increasing the speed. My dear, load angle is increasing means speed is increasing. So this is in higher speed than this much, this G2. So if you are increasing the speed according to the EMF equation, what happened? The induced energy will be increased, right? The voltage will be increased. So the real power flow will be higher for this and lower for this one. So power always have a tendency that power should be always flow from higher to lower. So what happened? Generator 1 will be delivering power. So I will use another diagram in order to clearly indicate that concept, my dear. Non-incoherent operation. So we can use this diagram. Okay. See. You can use this diagram, my dear. So del 1 and del 2. Okay, so what happened means del 1 is greater than del 2 means the electrical power or real power produced by PE1 will be flow from this to this one. That means generator 1 will be a power delivering device, generator 2 will be a power absorbing device. So power absorption means the power flow will be, the reactive power flow will be in opposite direction. Is it correct? Suppose I am taking from left to right as the power delivering generator, then the power absorbing generator will be in opposite direction. It will be in opposite direction. So that means it is absorbing the power. It is delivering the power means it is from outside out. It is absorbing the power means for this generator, the real power is absorbed by this generator will be same as the real power is actually in opposite direction, minus direction. You can say that one, that also, right? Is it clear? Here conventionally generator G1 is producing power. It is more power because its speed is higher than that of generator 2. So I can say that G1 will deliver power. So I marked it from left to right arrow because it's delivering power. At the same time it's absorbing power. If it is absorbing power means I should mark not like this. If I mark for generator G2 also like this means the power flow will be in the same direction. Is it clear? Is it clear? Power flow will be in opposite direction. That's why I have to mark like this. It is actually a parallel case, my dear. It is actually a parallel case. Okay, I will explain in parallel diagram. No, if it is more confusing, I will explain within a parallel. No? That will be very easy for you. Okay, don't worry. The same thing can be right like this. See, that is correct. G1 and G2. This is del 1 and this is del 2. Okay, so this will be the direction of the power P1. If I mark P2 also in this direction means it indicates that this also delivering power. It indicates that this also delivering power. Okay, so only way to indicate this power is nothing but, my dear, suppose this is in this direction now, so I can mark like this P2 and I can say that P2 will be minus P1. P2 will be minus P1. If I set like this, then correct. So in short, it is nothing but, my dear, this will be a power absorbing and this will be a this is delivering and this will be a power absorbing device. Is it clear? So I can say that P1 will be minus of P2. That's all. If a arrow is changed in same, both the vector will be in same direction. That's all. So P2 will be minus P1. Simple arithmetic. Okay, don't worry. So so P2 will be equal to minus P1. Okay, we have to continue. Okay, I'm rubbing this. I know this region, this area is slightly boring because it's analysis. This is analysis now, that's why. Okay, so what will be the swing equation? What will be the swing equation, my dear? We have m1 into d square del 1 divided by dt square, right, equal to Pm1 minus Pe1. Am I right, my dear? That be equation number 1. For machine 2, it will be m2 into d square del 2 divided by dt square Pm2 minus Pe2. That be equation number 2. Multiply it with the capital M2 and multiply it with the capital M1. Simple. I have to multiply it with the capital M2 and multiply it with the capital M1. And I have to subtract 1 from 1 minus 2. I am doing this operation now. So what will be the result? We will do step by step. So M1 M2 d square del 1 by dt square equal to Pm1 into M2 minus P1 to M2. Is it correct, my dear? Is it correct? This is and minus again m1 m2 into d square del 2 divided by dt square equal to pm2 into m1 minus pe2 into m1. Okay, the two equation will be like this. So we have to minus 1 minus 2 we have to done. So what will be the result? Since del 1 greater than del 2, so this is a common now, m1 m2 is common, so it can be taken outside. So like m1 m2 into d square by dt square of del 1 minus del 2 minus, my dear. Okay, d square by dt square of del 1 minus del 2 equal to can I write like, okay, pm1 m2 minus pm2 m1, okay na, minus of pe1 m2 minus correct na, minus pe2 m1. Is it correct, my dear? Is it correct? So this will be the relationship. So it can be same as that of pm1 m2 minus pm2 m1, okay, minus pe1 m2 plus pe1 m1. Am I right? Because we already took like pe2 equal to minus pe1 now. So instead of pe2 I can substitute minus pe1, so minus and minus get will be plus, that's all. So it will become pm1 m2 minus pm2 m1 minus of pe1 plus pe1, you can take it as a common, so minus p1 into m1 plus m2. Am I right, my dear? Am I right? So divide both sides with, so in LHS will be nothing but m1 m2 into d square by dt square of del 1 minus del 2. Okay, divide both sides with the m1 plus m2. So it will become m1 m2 whole divided by m1 plus m2 into d square by dt square of del 1 minus del 2 equal to pm1 m2 minus pm2 m1 whole divided by m1 plus m2 minus pe1. So this is the resultant swing equation for the two machine system if you are operated in non-coherent manner. If it is operated in non-coherent manner. So only thing you have to note very carefully that the resultant swing equation contain the m equivalent as m1 m2 divided by m1 plus m2. That is a real, important fact you have to note down. When it is in coherent operation, this moment of inertia will be add up, and when it is in non-coherent or incoherent operation, the moment of inertia will be like to be act as a parallel. So m1 m2 divided by m1 plus m2. That is the only result you have to remember. See, this analysis is for your knowledge, and the result is very very important. For series matlab for coherent operation, moment of inertia will be m1 plus m2. For parallel, for incoherent operation, it will be like a parallel construct, so it will be m1 m2 divided by m1 plus m2. That you have to note down. Is it clear, my dear? Is it clear? So that's all about the swing equation, which is expanded to a two machine system. Okay, thank you so much.